All right, so we're on to the second part of lesson 5.2. We have one more hint here. It says one of the techniques for simplifying is to rationalize the denominator. So if you look at the top of page 360, it says we look at 1 over 1 minus cosine x to rationalize that denominator, to turn it into something other than a sum or difference, or to get rid of it altogether. We're going to go ahead and multiply top and bottom by the conjugate. So if 1 minus cosine x is our denominator, we're going to multiply by 1 plus cosine x, because we know that simplifies to 1 minus cosine squared, which gives us sine squared, simplified. So we're going to multiply right here, step 1, multiplying top and bottom by 1 plus cosine x. We end up with this 1 plus cosine x over 1 minus cosine squared x, and we know that this guy simplifies to sine squared. We have 1 plus cosine x over sine squared, and I can extract, I can rewrite that fraction in this form, 1 over sine squared x times 1 plus cosine x over 1. You can see if we multiply these fractions, we get back to here. And so 1 over sine squared is simply cosecant squared times 1 plus cosine x. This is simpler. We've removed the denominator. We've taken care of the fraction. Let's look at example 5. So it's going to take this strategy into account. We're supposed to verify that secant x plus tangent x is the same as cosine x over 1 minus sine x. We look at this side. We have a fraction. It's going to be the easiest to simplify, and we see that we can use the conjugate in the denominator to get ourselves a simplified form. So we're going to multiply cosine x over 1 minus sine x times the conjugate of the denominator, which is 1 plus sine x over 1 plus sine x. We're going to multiply that numerator, cosine x times 1, cosine x times sine x, and our denominator simplified is 1 minus sine squared x. 1 minus sine squared x, Pythagorean identity, becomes cosine squared. And then we're going to rename this. We're going to take both parts of the sum above, cosine x over cosine squared x. That's the first part. And cosine x sine x over cosine squared x. That's our second part. So let's simplify the first. Dividing out 1 cosine x, we get 1 over cosine x. Dividing cosine x out of the right-hand side of the addend, we get sine x over cosine x. That simplifies to tangent. And the first one, 1 over cosine, simplifies to secant. And that's what we were asked to do, show that this was secant x plus tangent x. I'd like you guys to try number 55, and then come back and check your work. So problem number 55, sine over 1 minus cosine beta on the left, 1 plus cosine beta over sine beta. I'm going to start on this side, and the reason I start on that side is because I can use the conjugate to simplify. So I'm going to start with sine over 1 minus cosine. And I've written that here. I'm going to use the conjugate of the denominator. I'm going to multiply top and bottom by that. We get 1 minus cosine beta, 1 plus cosine beta, which we know multiplies to 1 minus cosine squared, which gives us sine squared beta. On the top, we get sine beta times 1 plus sine beta times cosine beta. So let's go ahead and look at what we've got now. If I take that apart, putting both parts over the denominator, I see sine beta over sine squared. That's 1 over sine beta. And I see sine beta cosine beta over sine squared, which simplifies to cosine. One of these cancels with one of those, sine over cosine. And we can see that we get 1 plus cosine beta over sine of beta. So in example 6, this is the first time we're going to have to do this or work with this process. We're going to simplify both sides and show that they have a third similar Pythagorean identity in common. So we're going to work on the left side first. Cotangent squared. Because I see cosecant in the denominator, I'm going to take the Pythagorean identity. Cotangent squared is cosecant squared minus 1. What we're going to do with that is factor the top part. Cosecant squared minus 1 is cosecant theta plus 1 times cosecant theta minus 1. And that is all over cosecant plus 1. We're going to rewrite that in the bottom. And we can see that these two cancel, and we end up with cosecant theta minus 1. That's our final answer. So what we're going to do now is take the right-hand side, 1 minus sine theta, 1 minus sine theta over sine theta. And we can see that we can break this up into 1 over the sine of theta minus sine of theta over the sine of theta. We've just renamed the fraction. And 1 over sine theta is cosecant of theta, and sine over sine is just 1. So we have proven that these two both simplify or can be rewritten as cosecant theta minus 1. You guys try number 57. Come back and check your answer. So for 57, we saw a difference of 2 cubes. So I've put a little side note on here, something that you used to know and maybe you forgot. The factorization of the difference of perfect cubes. So we're looking right down here. We can factor the numerator into tangent alpha minus 1. That's our first factor right here. And then we have tangent squared alpha plus a times b. That would be 1 times tangent plus b squared. And our b squared is 1 times 1, 1 squared. This is all over tangent alpha minus 1. And we can see that those factors disappear, and we're left with our solution, what we were asked to come up with. Let's look at example 7. So this time we're going to start on the left side. We're going to take our expression tangent to the fourth. We're going to rename it tangent squared x times tangent squared x. And we're going to rename tangent squared x, this second one, by its Pythagorean identity, which is secant squared x minus 1. And then we can go ahead and distribute tangent squared x secant squared x minus tangent squared x. We're going to work on the left side here. We're going to rename sine cubed x. We're going to call it sine squared x, cosine to the fourth x, and that final sine x at the end. I think you can see where we're going with this. And I'm going to rename sine squared as 1 minus cosine squared x. I've just renamed this first part. We're going to multiply that by cosine to the fourth x. That's this guy coming down, and sine x. So what I can do is take this first part and distribute it here and here. I get cosine to the fourth x minus cosine to the sixth x, and that is all multiplied by sine x. That's what they wanted. Let's do part C. Again, working on the left-hand side, we're going to rename cosecant to the fourth as cosecant squared x times cosecant squared x times cotangent of x. We're going to rename the second, doesn't matter which one, as 1 plus cotangent squared x times cotangent, not squared, x. So if we distribute this to both terms in the binomial, we get our first cosecant squared x, we get cotangent times 1, and we get cotangent squared times cotangent, which is cotangent cubed. You guys try problem number 69 and come back and check your work. So you can see in problem 69 we have taken tangent to the fifth power, renamed it as tangent squared times tangent cubed. The reason we want to name it as tangent squared is so we can use that Pythagorean identity. Tangent squared is secant squared minus 1. We've renamed this first one, and we've left the tangent cubed. You can see if we redistribute, we get tangent cubed, secant squared, those both have x's, minus tangent cubed x. Please look for your lesson on PowerSchool and get a lot of practice with these. Practice might not make perfect, but it makes it easier to do when it comes time. Talk to you later. Bye.